The robot operating system is powering robotics R&D around the world, including penguin conservation robotics in Antarctica, the Robonaut 2 on the International Space Station, and a skin printing robot medical device being developed right here in Sydney. One of ROS's fundamental features is its support for cross-language communication, allowing messages to be passed between processes running Python, C++, or any number of parallel programming languages in parallel. This talk is about the Python module at the heart of ROS's cross-language support, the EmPy template system, including a minimal reproducible examples so you, and I mean all of you, can get started making templated code for your own projects. Let's give her a hand.
And audience participation. But I feel like it should be louder. So just,
Louder here.
okay, thanks. Maybe I just like the sound of my own. Yeah. Cool, thanks. So, as mentioned, I'm here to tell you about something that I find interesting. So I'll just ask to start off with, who here likes robots? You might be disappointed. Because this talk is about what's underneath robots, not robots themselves. Primarily, we're going to be talking about EmPy, something that I find interesting, and it's really just so that you know about it because I think it's cool. Who am I? I am a robotics engineer. I've been doing software and electrical engineering for 10 to 15 years now, depending on how you count, and I'm an engineer for good. So I like to work on projects that have positive applications in society, and as my secondary impact on the world, I like to tell young people about these positive career pathways in STEM. Try to get them as excited as I am about technology, not just for its own sake, but for changing the world. So this is, thanks. Yes, I still hear an echo, but it's not. No, it's just like this. Thanks. Testing again. That was possibly better. Yes. So this, I don't always get to talk to young people about like the technical nitty gritty, although I have explained PID controllers to a group of year 9 girls before, just like, why not? But tonight I want to tell you about ROS, and it's, for me, like a really powerful project because of how the robot operating system, as you heard, enables roboticists around the world in interspace to make all sorts of robots. So we are, I say we because I used to be one of the lucky ones who got paid to work on open source full time. I was part of the ROS2 core development team during the days of the bouncy release. We're up to, I think, 8 total now, and I still can't stop myself from saying we. But this is, as I mentioned, a framework for roboticists to do cool robotics work, and I want to tell you about a Python module that then powers that framework that then powers the robotics. So this is by Alcione Systems, that as far as I know is just somebody's side project, but an homage to EmPy will now follow. So for you, my motivation is just like, my goal is just familiarity, that maybe if you see something in your side projects or possibly your professional work that I find side projects more fun, that you just be like, oh, maybe I can use EmPy for that. I don't personally mind if you do or don't. I'm not really financially attached to any of these things because they're free and open source. But I don't want to start right with like a ROS demo because it's a bit early to make your eyes bleed with those intense templates. So I've created 1 or 2 like smaller examples and a little sandpit that you can kind of, you can even load and run the sandpit on your phone with this thing I found. But to start with, like, just what do I mean when I say templating? Because like in C++, templating in the language has a very specific meaning. I just mean like in English, templating, I'm talking about like injecting stuff into a text file. And that stuff could be Python variables, expression logic. So just putting Python into text that could be Python code, or it could just be regular code. So mini Chin's example. This is like the simplest template that I could make. I guess you could go simpler, but this is just text. This is what we're going to template, and it's going to be combined with some data that gets input into the template processor, and these two things are going to merge to make an output. I think this is what you expect. It gets more interesting. So this is like a variable extension. Again, this template can be a text file, an HTML file, it can be an SVG file, it can be whatever language you want, because the template processor doesn't notice anything that's not the sort of part of the markup. So here is a Python expression that you can put in the template, and then it will embed the evaluated expression. Cool, cool. What we find most useful in the ROS applications that I'll tell you later on is that you can do this control flow, and this is where it gets really fun for automation, that if you for some reason needed to put blocks of code 5 times in your hypothetical text file, then you could just do it with this for loop and you'll get it output 5 times. So I think this probably matches what you sort of expected with the idea of templating, but I do have a demo, although I'm going to run it. I think it'll be easier if I switch to Firefox. So I have put this in a little sandpit with a binder, it's called. I wanted you to be able to walk away with something that's not ROS code, because it's not the most usable. So all that's in this Jupyter notebook equivalent, or super notebook when it gets set up, is just a Python installation of a very simple requirements file that all it contains is EmPy. That's the only requirement for this demo. And I have created just a very simple template. That's a text file, and I've chosen to put this .em extension on it just to distinguish it from regular files, but that's just optional. And so now this has been loaded into this environment that is a bit bigger now. So all we have to do, and again, this is just building blocks. This is our template, and here's where we input a Python data, and this is what we actually want to happen. And so we can invoke the EmPy system either by importing it into our Python runtime or just by calling it from the command line. So sometimes you can just call it with m.py, but at least in this setup, I'll do it the long way. And we just ask it to instantiate this template, fingers crossed everyone, line of demo, and it is working. And if we go and modify some of the Python configuration in this, but it could have been imported from another file if we wanted, then it will change the behavior of this template, because I've added a bit that it's conditional on what our data is up the top. And now it should show that for loop that we expected. Cool. The one thing that is sort of an edge case, I suppose, or why I wanted you to have this sandpit is because each of these lines, even though they're not asking anything to be output, they do still add contribute white space. And so you can choose or not, depending on your application, to add these ampersand at symbols at the end, and that will just condense that white space. That's just the first little hands-on tip. But otherwise, we just did a template, and if you want to follow along at this repo, it even works on your phone. It's Jupyter Flat. Right. What's next? So we're still, I think, not ready for the ROS template. But I do have some examples of maybe more side project applicable usages of the EmPy library. So they're just fictitious, but I personally could use any sort of mail server to send invites to my friends, but I'm the sort of person more likely to make one myself just for the fun of it. And in that case, we have everything that we need to do the customized invites, at least, that we do the variable substitution for the name, but you could also customize other properties of the invite if you wanted to, based on like how much you like different people. Like the possibilities are endless if you want to tell them to come at a different time or to go to a different place, like it's up to you. And then you can choose as a developer if you want to do that customization in the template itself. You saw that we can embed Python code in the template, or you can have some other module that does some fancy processing and just passes in the result into the template as the API interface. So bigger picture, this means that if you're working with teams of just designers, and the designers can touch, because this could be an SVG or like some file that they don't care about where the input comes from, and you can decouple these in terms of like the version control. These can be touched by separate people. But what is maybe interesting about this hypothetical example is that rather than just instantiating the template once, you're going to be using the same template and instantiating it multiple times, depending on how many friends you have. You'll be instantiating it more times. And so probably there's going to be like a wrapping, maybe Python suite that will be calling EmPy. This is where you're less likely to call it from a command line or more likely to call it from within by like importing the module yourself. But this one's boring, so I didn't implement it. But you could probably like open a pull request to the demo repo by the end of the night if you wanted to, but I'm not motivated to do that. I'm motivated to do a different demo for this event. So it's my demo, so I can choose the requirements. We are doing a lottery for everyone in attendance, and some people who RSVP'd and didn't show up. And what I want to happen is that the winner of the lottery is revealed from an HTML page with like no JavaScript, because today I don't like JavaScript. And I just want it to be like one of those great 90s pages, like GeoCities. And I want it to be like the old times. I'm just going to rename this so that it can be displayed, but this will be the template that's displaying. But this is my vision. Trying out. Yeah, I made this just for today. So,
Certainly name is type.
it says created with Notepad. So let me get back into my talk, because you're all going to know what you win hypothetically when you're drawing from this lottery, and it's gonna be a group effort that you're gonna win a celebration and a high five. Yeah. So I need to do one thing, which hopefully is on my clipboard, just to add in the participants. I also need to change this back to the template name that it's expecting, but soon we will have our participant, like our winning participant of the what's that show called? Price is Right. Is the music making sense now? So, all we have to do to determine the winner is just run this bash script, and if you wanted to like deploy this as a daily lottery, you just need a cron job that runs this bash script, and that's your web server, right? So, got to get into that directory, got to build some suspense. We're just gonna run this one. All this is gonna do is instantiate the template. The winner won't be revealed yet until I choose to display that. But before I do, I just want to remind people what we're going for here. This is a team effort. And if this person is near you, then you got to really hype them up. And if they're online, they have to yell loud enough that my muted computer can celebrate them. Are we ready?
What extent on?
If they're not here, they're probably pretending, and you should just give them an elbow if you know them.
Sure. They'll give you another.
Sorry,
I run
a runner-up. Look, oh yeah, I meant to show you the template. It's not very interesting. But this is the thing, it doesn't have to be complicated to be a useful template. And you'll see that in Ross, like we don't, those for loops, like that's all we use, but we do it for a really interesting reason. So it just embeds winner is just random choice. This is what we're doing, there's nothing complicated. But the winner has been chosen a minute ago, even. I'm gonna get mine easy. But we're ready. Valerie. Oh yeah, that was, I feel like you cheated, but I'll allow it. So now you can do what you, this is the end of the sandpit stuff, but you can do what you want with that because you saw that it just brought that up from nothing. So if you want to try out EmPy stuff yourself, I suggest you use that link, but you do it one. We're ready, I think, for the buff doge. So how do we actually use it in the real world? Like I said, it doesn't have to be complicated. Oh, why? Why would we use this in the real world? Well, I told you the robotics, yeah. It's used in ROS, but particularly it's used in ROS to enable cross-language support from different nodes. So ROS allows for anonymous pub/sub between different nodes that can be distributed within a robot, but also between different systems. And so in this application that I worked on a number of years ago, this is a robot that I developed for children with handwriting difficulties so that they could teach the robot how to write instead of being corrected all the time. And part of what allowed this to be possible using this robot that does not have the dexterity to write was using this Android tablet, which runs Java. So there are C++ nodes on the robot. There's a synchronized tablet that just like pretends that the robot is writing, running Java. And then there's an off-board computer running my state machine and like the learning algorithm that I developed for in like learning from the children. So that's my real life example of using cross-language communication in ROS, as well as the lower one where I'm at Inventia Life Science. I worked on a skin printing robot in collaboration with Professor Deanna Hood to improve the healing outcomes for people who have survived burns. And we do that by skin regeneration as opposed to a skin graft. And these robots have a Java API. They run Java applications. I have an off-board computer that runs C++ to interact with them. And then we choose to develop our printhead systems using Python. So there's another like 3 language in a single robotic system, at least at the R&D phase. This is not uncommon. So how is it made possible by EmPy? Okay, so we're going to move away at the end of the robots. We're moving into more like abstract concepts because that's what ROS is really good at. Is like, I care about the now in the upper instance, the robot taking a picture of a tablet and then passing it to a tablet detector process, for example. But ROS allows us to abstract this so that it can be used more generically because it allows this like plug and play ecosystem of robotics is sort of sharing their different modules with each other. So someone else might have developed this tablet detector process. They don't care that the camera image comes from that robot. It could come from simulation, all this kind of. And the publisher is just going to publish a generic image message as a result. And that could be consumed by a tablet process. It could be consumed by some other process that's interested in an image for whatever reason. And this is where, like, you never know who's going to consume your ROS messages in general. So this abstract message can be useful. But you also don't know what language is going to consume it either. So suppose you knew that you were talking to a Python consumer, then you could just send them over your image object once you have a way of doing that. But beauty of ROS is that ROS2 especially, and I have another talk about how we enable so many client libraries in different languages to be developed by the community. And so you don't know who's going to be consuming it. So instead of passing like Python objects around, we choose to get them to like C structs that then can be passed to other languages. And this is where templates start to get involved, because the messages, so I'm talking about an image that, you know, in robotics, you also have messages that represent like the destination of a robot in its navigation algorithm. And we have so many message types, and users in the community, developers can define their own types. And I'm not gonna make the support for like serializing them by hand. We're gonna do it with templates. So where EmPy specifically helps in ROS is to generate these objects that can be used for the message types, and then to like create the conversion functions of these like hypothetical messages or like infinite combination of message types into the C representation so they can be passed around. So sticking with the image message, it has 4 fields. One of those is another message in itself, but don't mind that. So it has 4 fields, and we need then the output of our template to contain these 4 fields that have been represented in the file before, which was just like a text file pretty much. That's how we choose to allow roboticists to declare the abstract form of their message that's language agnostic. This is not language agnostic, this is specific to Python. So a Python user working with an image needs to access this class. And also they need to be able to set different fields, and we choose to provide type checking based on what properties of those fields were declared in that message definition file. So this is where templating comes in. And specifically, the example with the object, we have like Python modules that will pass these message definitions. And then we've got the Python data that we need to pass to EmPy and output what the user of the client library needs to interact with. And we do that. Look, it looks the same pretty much as the like dummy example, because it doesn't have to be complicated to be useful. So this for loop is like, I've got 4 fields. For each of them, define a slot. Like it's a lot of work to get to this. But in the end, the template itself is not doing anything particularly sophisticated. So we do the same thing, as I mentioned, for different languages, but also different parts of the serialization process. There are lots of templates. But suffice to say that we lean on EmPy for that. And just by choice. I mean, we could have chosen other ways, I'm sure, but once you end up with support for a library, you kind of start using it everywhere. So this is what the templates actually look like, or at least looked like at some point in the commit history. Let me find, so look at all of these at symbols, that's all EmPy. So this is a 500 line file, and it's nearly all templated. So this is not just like a trivial thing. not just for whatever dummy examples I showed before, but somewhere there's going to be a for. So for each of the yeah, this is more where are our slots. Just find the, okay, so for the member in, this is our parsed data that came from processing the IDL file. So we're just going to embed that there. And then we also had something about type checking, integer can't be, yes, this is the, so for all of, for each of the fields, so we're iterating over each of the fields, and then we just check, well, what type is it? And depending on what type it is, we'll put different checks in the setter. So if it's a field of a type string, then we'll embed the string type into that object. And if it's one of these ints, then if it's a signed int, we'll allow a negative value, and if it's unsigned, then we'll allow negative value. You see we have like a Python evaluation is happening here, as well as just the substitution of variables, and then of course lots of logic flow. So this is the Python, a real true Python template from the ROS project, and then the equivalent or like a similar thing for a C struct, just still Python code around, and that's actually like the same sort of Python data that's being held in the template. It's just that we're instantiating now a C template instead of a Python one, and before we were doing HTML. So you can use it for whatever. If you're interested, I have another example that's also not Python, which I think is even more interesting, but I appreciate that I have a unique, I'm interested in everything, and not everyone is, but unless somebody gets up and walks away, this is our last example, and it is another real world example. So the cool, do a dog, did you say?
I said it's your dog.
Yeah, well, that's true. So being one of the early developers on ROS 2, which was a rewrite of ROS, I got to work on some of the like fundamental features, and I implemented the logging features for the different core libraries, Python, C, and C++. So we have our notion of loggers in ROS that they do as you would expect in terms of like, you can set the severity level and then filter out messages that are below the severity level that you care about. But we also allow some extra features like skipping the first message and only printing once if you hit that particular line, and not printing messages at a rate higher than 10 Hertz, for example. So this in Python doesn't need to be particularly time critical, this sort of logger evaluation, but in real-time applications, people working in C and C++, those client libraries, they don't actually want the logging to even check the severity level at runtime. You want it to be compiled out. And the way that you can tell the compiler at compilation time to exclude code is through compiler doesn't matter. They need to be macros, isn't it? So you can't just define a function like you would with the logger in Python, but you put a macro. So these macros have these names, like every macro exists for info, diva, the different severities. I'm not gonna like write that myself. And then it also exists with all of these different feature combinations, and I'm not gonna write that myself. So what I did instead is to just import some Python. So we share, it doesn't matter. I get there's another talk on this, but I get the information from a Python module. The data comes from something external to the template, and then the template just uses it. And the way that it uses it, again, is very simple. It's just a for loop. But for each of those severities, it's gonna sort of put the same cookie cutter code in there. And it's probably less interesting the rest of the implementation, but the cool thing that you can imagine is going to be happening even without looking at the implementation is that if we want to change something about how the macros are used, so here's a follow-up pull request where actually now we're not going to pass a name and we're going to pass a logger object. This is like tiny, but then it created, once the template is instantiated, it of course makes a much larger diff because of all of the different combinatorial, like combinations of the different features and the severity levels. And so you don't need to worry about having to change it in every place. You just change it in one spot, and then because of this cookie cutter, so I'm not just being lazy, you could argue that this is like safer code. If you find it useful to have the templates, it might be overkill if you don't have, if you don't already have like the infrastructure for instantiating the templates. But this is a C++ package. It doesn't know, it cannot depend on Python for like circular dependency reasons, but it's on the Python client library, I mean. But it doesn't have to, because for anyone that works with CMake, you just invoke Python, you invoke the EmPy module on that while you're in your CMake list. So you don't need to, this is not, I'll say again, this is not just a tool for Python projects. This is a Python enthusiast injecting EmPy wherever I see the need and getting things merged. So that's, I reckon, a good place to start summing up. You've survived the mega examples, and just reminding people that this is what powers ROS, that powers robotics, and maybe it can power your side project. It's up to you. It's now powered one of my side projects. That was a nice experience for all of us. But here are some references, including the one to get to that sandpit if you want to work with this library yourself. And I said I'd share it with the maintainer. So if you want to wave to the maintainer of EmPy, but otherwise, thanks for coming to my template talk.
Thank you so much. Time for a couple questions. Any? We're not leaving till we have at least one.
How far away from Scotland?
Already here.
Sorry?
How far are we away from Scotland?
Oh, if I told you, I'd have to kill you. Yeah, I mean, a lot of ROS, so I say it's like anonymous pub sub, but actually these days, there's a lot of work done in like secure versions of ROS, so that it is, you only subscribe, allow people to subscribe or control your robot based on like certificates and handshakes and so now, at least when it comes, it'll be secure, right?
Oh, and one more here.
What's your favorite project where you've actually used EmPy and or ROS?
I think if I can take credit for other people's projects.
We're an open source community, you definitely can.
Then I think the thing that I find like the most exciting is that ROS 2 now is part of the NASA Viper project. And like, it's not all of the NASA Viper project, but NASA has publicly said that they're using parts of ROS 2 and probably the logging Hey. So, yeah, and that's where it's nice to, if you find something that you want to improve in anywhere in the stack, then you can also, feel that sense of pride. Like they keep giving me badges on my GitHub for contribute. I think I'm in, there's something about a Mars helicopter project. Like if you contribute to these, and I don't know anything about that, but apparently, like if you use OpenCV, if you contribute, I just like to contribute to things for fun, and you get some badges for it. And I can do a talk. I contributed to Python as well, so if you want to hear about that process, I can tell you another day.
Probably a silly question, but I noticed you had a few of the jobs.
Sorry. Microphone, please. Sorry, we use the microphone because not everyone can hear as well as everyone else. Accessibility and just use the mic.
Okay, I'm just curious, it might be a silly question. I noticed that some Japanese robots, and I thought they'd look at them. The ones that dance, do they actually use ROS or would they just use ROS for something else?
The small orange ones.
No, it was the silver one, the one with the spot. Not that one, the other ones they put on stage.
In YouTube video.
That one.
That.
Yeah.
Every robot in this video is publicly using ROS. And I have forgotten the question. I'm sorry.
Well, it's asking if it's being used in Japanese robots because they use quite a few only with the controls like the scene, the dance, the walk. So they don't put it in.
Yeah. So I guess in my experience, it's often a combination. So the stack for this robot, for example, the stack of that looks like Aldebaran, now SoftBank, made an API for using the Now robot, and then also some of the developers, actually made like the pipe and the ROS support for that robot as like a layer on top. And then by doing that and releasing that to developers like me, I was thrilled because I could do ROS support, particularly between the tablets to have that cross-language communication with ROS. I wasn't like instantly, but it was stuff that I didn't have to develop. And as a result, those developers of the ROS driver, they like when I meet them, because we have like ROSCon event, we're like, we never thought that anyone would use that robot for this sort of application. Because when you release things into the open source, like you don't know what people are going to use it for, and that's where it's like, I don't know what you're going to use EmPy for, and the developers and maintainers of EmPy never expected any of it, sure, and that's where it's exciting to empower other people. I think that's what ROS drivers allow, because of how it's not just industry, it's not just researchers, there's also hobbyists and artists using ROS, and there are some really amazing art projects that are using large industrial robots as well as like the cool ones that I probably no. They are and the robot is good. Thanks. They asked me the session bus as a joke if I could get the robot of the medical device to be to centrifuge the cells. Like I'd rather not.
Awesome. All right. Well, let's round of applause for Deanna here. All right. So that concludes our Sydney Python for the month. Our next one is Thursday, September 22nd. We still need 2 speakers for that one. If you want to speak, it's a lot of fun. Anyone can come up here and talk about cool stuff. Robots, Python, anything.
If you need an excuse for a side project, like
There you go.
I had a wonderful time.
Little Bird Australia just dropped the Raspberry Pi, the Pico, $10. Put MicroPython on it. Come talk about it. About 3, I might do it. If you want to come talk, send us a message to myself, I'm Sean, and to